Alright guys, this is a review of what we did on the first day of IE2 review. So these are the questions also that you have in your packet. I'm going to go ahead and work through a couple of these here. That way you have them for reference. So these right here are telling you to solve the equations. So I'm going to have to look at my unit circle. Okay, so again, this is something that try and finish. You don't have to go all the way. I mean, try and get all the way through, but if you can't, you can get still partial credit if you work through some of the problems. So we're going to do number 2 first. And what we're doing here, okay, first let's look at both sides. Here I see that I have cosine squared and cosine squared, so that to me means I can combine the two. And right now what I'm gonna do is I'm gonna move this cosine squared over to the other side, so it's gonna be plus cos squared plus cos squared, so it cancels on this side, and right here it is 3 plus 1, which is 4 cosine squared equals 1. Now remember, I still want the cosine by itself, so I'm going to divide by 4. Divide by 4, so I'm left with cosine squared equals 1/4. Okay, now this is squared, so I still need to get rid of the square part, so I'm going to do square root, and I still keep seeing a lot of y'all forget this. When you do this, you have to have a plus and minus. So cosine theta equals the square root of 1/4, which, guys, this is plus or minus. The square root of 1 is just 1, so we can leave that on top, and the square root of 4 is, oops, that's not very good, but it's a 2. So this is the point now where I look at my unit circle. Remember, the cosine is the x value. So I look at the unit circle, where does my cosine equal? Either positive 1/2 or negative 1/2. So I don't have a unit circle here in front of me, but if I were to do this, I would look at my unit circle at pi over 3, it's 1/2. At 2 pi over 3, it's negative 1/2. At 5 pi over 3, it's negative 1/2, and the last one is, I'm sorry, 4 pi over 3, it's 1/2, and at 5 pi over 3, it is positive 1/2. So this is the answer for number 2. Okay, moving on. So we have a similar type problem. I'm sorry, we're going to do number 4. Here I have cosine, and here I have sine. Okay, so one, I have to have only one trig function, which I don't have right now. This is sine squared. This is cosine, so they're not the same. So what I want to do here is to change this sine squared to something with a cosine. So since this is squared, we have an identity: cosine squared plus sine squared equals 1. Okay, what I'm going to do, okay, is change it so this equals sine squared. So I'm going to subtract cos squared, so sine squared equals 1 minus cosine squared. That's what I'm going to replace with sine squared. Now I'm coming back to the original equation. So this over here now becomes 1 minus cosine squared equals, excuse me, 1 minus cosine squared minus 2 equals 2 cos theta. Okay, we can leave it like that. So I'm going to combine 1 minus 2, so that becomes negative 1 minus cosine squared equals 2 cosine. And what I'm going to do is move everything to this side. That way I can deal with a positive cosine squared. So plus 1 plus cosine squared. So this is cosine squared plus 2 cosine plus 1 equals 0. Now, at this point now, I have everything on one side. I can factor. Okay, so this is where I'm going to do my parentheses. Since this is a positive one, these will both be 1s, and this is going to be cosine and cosine. This is a plus in between, so this means that these are both positive signs, plus and plus. And now I can solve. Cos theta plus 1 equals 0, and since they're the same, you just do this once. So minus 1 minus 1. Cos theta equals negative 1. So now, like I said, you go to the unit circle, and now I'm looking where does it equal negative 1. And since we're dealing with cosine again, where's the x value equal negative 1? So on this one, if you look at your circle, you're going to see it only has one answer, at pi. And I should have circled these as well. Okay, so again, guys, this serves as a review for what we did on Monday. So that's all for this video.